All right, turn in your textbook to page 137. This is going backwards. We're going to estimating with percents. And at this time, go ahead and pause the video, complete the what you'll learn and the real world link. Okay, let's take a look. What are some things that you came up with to predict about estimating with percents? What did you write? Quinn?
A bar diagram.
Okay, something we're going to learn about bar diagrams and how to use them. Good. Nia?
Estimating using a rate per 100.
Estimating using rate per 100. Anything else you wrote down? Yeah.
A survey.
We're talking about things that we're going to learn about, right? So the survey is almost a real world application, but something we're going to learn.
Finding compatible numbers.
Good, using compatible numbers. Take a look at our real world link here. Josephina surveyed 298 students and found that 52% like scary movies. Estimate the number of students that like scary movies. So if you had to go and fill these percentages in for number one, how many groups did you have here? How many groups were there? Bailey?
4.
4. So because there were 4 groups, we had to determine what our percentages would be. What's this first one at 75? 25%, then 50, and 75. Okay, so that completed question number 1. Then we looked, what common percent is 52% close to? So if we look at 52%, it's close to 50%. So we're estimating that percentage. Shade the bar diagram to show your answer. So we would shade this up to 50. Okay. Round 298 to the nearest 100. 298 is closest to 300. So that means that this here would be 300 is what it's close to. Then it said to use the bar diagram to estimate 52% of 298. Well, if we go 52%, we had this 50% here. That's close to 52%, right?
Yeah.
And 298 was pretty close to 300. That's the whole thing. So 50% of 300 would be 150. Does that make sense? Is 50% like a half? Is 150 half of 300? Yeah. So that's a logical, reasonable answer for us to get there.
It's like 15 and 30.
Yeah, exactly. Look at number 5. Use the bar diagram to estimate 73% of 400. How many groups do we have again? 4, so we're going by what percentages? 25, 50, 75. What if they had 5 boxes? What would we be going by? 20%. What if they had 2 boxes? 50. Okay, so we could use that. Then we're going by what here on the bottom? By the hundreds, so this last one should be 400, which that makes sense because that was here. 73% is pretty close to what? 75%, which is here, so our answer would be 300. Now, we have already done percent of a number, right? So isn't this 73% of 400 something we've done? This is why we actually flip these 2 lessons around, because I think it'll make more sense. Because we're estimating, do we want to use 73%? What's close to 73%? 75. So we could change this to 75%. This is still a pretty nice even number, isn't it? So we'll keep that at 400. Change 75% to a decimal, which would be 0.75. Move that decimal back 2 places to the left. Divide by 100. Of means to multiply by 400. If we did that, 0.75 times 400, would we still get the same answer? Yeah, so the bar diagram is a visual representation of what we have here, but we can also solve it using percent of a number. Turn to page 138. Okay, estimating with percents provides a reasonable solution to many real-world problems. I'm going to be very honest with you. Estimating with percents, I think, is a really, really important skill. Where in the world would we estimate with percents? Why would this be a really important skill for us? Autumn?
Surveys.
Surveys, okay. So some of you may do surveys someday, right? Where are we all going to use estimating percent of a number? Christina, how so when you get a paycheck? It could be if you're getting your paycheck. For an example, when I do my tithes and offerings at church, I give a certain percentage of my paycheck towards offering. So I could find that from a paycheck. Could be if you're doing a budget, could you find that, okay, this month 30% of my money is going to go towards Christmas presents, and then I'm going to set up the rest of my budget around that? Could that be something where we use percent of a number? Okay, so that might be one way, but I'm thinking something that you're all going to do at some point. You're going to see these finding percents of a number, and you're not going to want to pull out a calculator and figure it out. If we could do it right away, we'd be even better off. Zach?
Like grocery shopping?
Okay, so how do we see percent of a number in a grocery store?
Like you have to estimate the price of something.
Okay, so if there is a, what? A sale. How many of you would rather spend less money on something if you can help it? I am a bargain shopper. Why spend more money on something? Because then I get more money, I can buy more things, right? That's an American philosophy. Okay? But percent of a number, when I go shopping, I don't think I've bought a Christmas present full price yet this year. I don't think. That I can remember, I don't think I have. Okay, so last night I was shopping at Kohl's. Okay, they had something, I had a 30% off coupon. Well, if I have 30% off, as I'm going through the store, I'm thinking about, okay, if this is 30% off, what is its price going to be when I get to the register? Is it worth it? Sometimes 30% off might make it worth it. Oh, that's a pretty good discount. Oh, it's already 20% off and I have another 30%. Okay, so I'm calculating as I'm going through. Am I going to pull out my calculator and solve that? No. I'm going to find 30% of something. So estimating with percents becomes a very important skill. Also, when I go to a restaurant, what would I estimate there? That would be percent of a number. Leah? Yeah, your tip and maybe even your tax a little bit. Tax, I'm usually not worried about. It's just something you pay, right? But if I'm going to tip my waiter or my waitress, I'm kind of calculating and estimating what my tip should be depending on the size of our bill, kind of like we worked on last week. So let's talk about some mental math strategies with estimating for just a minute. Anytime you see 10% of something, okay, anytime we see 10%, our number system is based on a base 10 system. That means that if I move to the left, one decimal value, I'm dividing by 100. If I move to the right one decimal value, I am multiplying by, let me say that again. If I move to the left one spot, I'm dividing by 10. If I move to the right one spot, I'm multiplying by 10. If I move two places, I'm dividing by 100. If I move two places to the right, I am multiplying by 100. So because of this base 10 system, if I look at a 10%, I can find this mentally pretty fast. Okay, 10% let's say is what you want to tip when you're at a restaurant. I prefer 15, but maybe some of you do 10%. Let's say your bill, it's 10% of $29.64. Well, there's two ways you could think about this. We could change that to 30, couldn't we?
Yeah.
We could, but I want to do exact. So if I want to find 10% of it, 10% of this, how far am I going to move that decimal in our base 10 system? Christina? Say it again. If I move it twice, how far is that? What do we find when we move it twice? This is a skill from this chapter, ladies and gentlemen. If I move it twice, what's happening? Caitlin?
Moving it times 100.
Times 100 or divided by 100, right? Because that's two places. So what happens if I move it one place? Cameron?
You're dividing or multiplying by 10.
I'm dividing or multiplying by 10. Do I want to divide or multiply here if I think about that? Do I want to get bigger or smaller for 10%? Smaller, definitely, right? So I'm going to move that decimal how far? One spot to the left. So if I move this decimal right here, one spot to the left, what does that become? $2.90. What's that for? We're going to do the 6. $2.96. That would be what my tip would be. I get frustrated sometimes when I go to a restaurant with one of my sisters because we go to do the tip and she pulls out a calculator. Like, it's 10%, just move the decimal. No, I'm just going to use my calculator. Okay, let's try this one. What if I have 10% of $56? Where's my decimal in 56? Tori? Right here, right? So if I want to find 10% of it, what am I going to do with that decimal? Valerie? Which gives me $5.60. You see how that works with 10%? Okay, so let me ask you this. Let's say they ask me for 15% of 50. Now it doesn't work so well, does it? But what could I split 15% into that might be easier for me to handle mentally? Christina? I could do 5s, but that's not very easy. What were we just splitting it into before? Our number system is a base 10. So couldn't we split this into 10% plus 5%? Because 5% would be what to 10? It'd be half. So once I find 10%, could I find half? So let's do 10% first. So 10% of $50. Where's my decimal in 50? Tyler? So if I move it back, how many spots? 1, I get $5. What's half of $5? So 5% of $50 would be $2.50, wouldn't it? Does everybody see where I got that $2.50? Half of 5. So what would I do with those two? Add them together, we get $7.50. So 15% of $50 would be $7.50. Could we do that with 20%? 20% of 50.
Yeah.
What would 10% of that be? $5, but we need 20%, so how many of those would I take? 2 of those 10% would make $10. Now this was the one I was doing at Kohl's last night. 30% off, right? 30% of $50. Well, what would 10% of 50 be? $5. If I need 30%, how many 10% is that? 3 10% would give me 15. Now this is my discount, right? This is not my value. That would be my discount. So if it's $15 off of 50, what would the cost of my item be?
45.
Careful. 35. Okay, so then I could determine, depending on the item, if it's $15 off, that's kind of a lot, isn't it? So I'm thinking, okay, it's going to cost me $35. Is that worth it, as I'm standing in the store? Do you see why this mental math is going to be kind of a critical skill? Yeah. You want to know, hopefully, when you get to the register, how much you're going to pay. Now, I'm on a teacher's salary, right? So I need to know what I'm going to pay when I get to the register. I don't have a lot of extra cash just lying around. Okay, so those are some mental math strategies we could use for this. Okay, we don't have to use mental math. So let's take a look. Number 1, let's talk outside the bar diagram. What's 47% close to? So we're going to change that to 50%. What's 692 close to? 700. How do we find percent of a number? Sam?
We make the percent into a decimal.
Which would be?
It would be 0.5.
Good. Of means to?
Multiply.
And we're finding of 700. Now, most of you, you're thinking 50%. 50% is the same as half. Could you also be thinking about what's half of 700? Would we get the same thing? Yeah. 0.5 times 700 gives me 350. Does that make sense? Is that a percent? No, because I'm finding the amount that is that percent, right? Look at number 2. How would we estimate 60% of 27? Do we really need to change 60%, do you think?
No.
So let's keep 60% at what? 60. And 27 we could go to 30. So change this to a decimal. What do we have? 0.6 of means to multiply of 30. See why we did percent of a number first? So 0.6 times 30 gives me 18. Okay, let's try the got it together since we're running a little low on time today. 48% would go to what? Everybody should have pencil in hand. 50% of means to. Okay, so we're going to change 50% to a. So 0.5 times. What are we going to change 76 to? 80. Gives you what? 40. Okay, 18% we're going to change to 20% of. What do you want to go to there? 40. Change this to a decimal, it becomes 0.2 of means 2. And we'll keep 40. Solve. 8. Very good. Okay, 73%, what do we want to change to? 70%. Could you have gone 75%? Either one. Of 40. 70% becomes 0.7 of means 2. 540 gives you
28.
Okay, do you see how that works? Is it really different than what we've been doing? Nope, except for estimating. You could have done 75 too.
Yeah, but the answer is 75 would have been 30, right?
Yep, either one would be fine. It's an estimate, so as long as we're close. Take a look at example 3. Polar bears can eat as much as 10% of their body weight in less than an hour. If an adult male polar bear weighs 715 pounds, about how much food can he eat in an hour? Well, we've got 10% of 715. Do you agree? Okay, so 10% we're probably going to keep at 10%. Agreed? Of, what do you want to change that to? 700. This becomes a decimal of 0.1 of means 2 of 700 gives you 70. Could we have done a mental math thing there? Why? Because it was 10%, right? Could just move the decimal over one spot in 700. Okay, look at our got it. Kaylee decided to donate 30% of her savings. If she has $238 in savings, how much will she donate? So she's going to donate 30% of what? Of 238. We're going to keep this at 30%. 238 we could go to what? 240 maybe is closer. So 30% would become 0.3 times 240. What do you get? That would be close enough. 72. So she's going to donate $72. 200 would be way too far away. You could have gone to 250. That'd probably be okay. But 200 is too far away. Okay, here's the last little thing. This is rate per 100. Okay? It says estimate 17% of 198. Well, every percent means out of 100, right? So when we see 17%, this means 17 out of 100, right? So what if this was out of 200? What would we have to do? Double it, which would make it. So what we're going to do is we're going to keep the percentage with rate per 100, and this is going to go to a value that's close to a multiple of 100. So what's the closest multiple of 100 there? 200. Well, how many 17s would be in 200? 2, because there's two 100s, right? So this would be 17 times 2, or you could think about it as 17 plus 17. What if this had been 400? Then you would have 17 times 4. Does that make sense? So rate per 100, you're just going to change this one to a multiple of 100, and then you're going to take this times how many 100s there are, because it means out of 100. For tomorrow, go to page 141. You are going to complete for me Notice that on 5 and 6, it says estimate using rate per 100. We have to have exactly the same answers there, okay? For tomorrow, let's go 1 through 8. Okay? Page 141, 1 through 8. Okay? That is due for tomorrow. You can go ahead and get to work.